Okay, Bismillah ar-Rahman Rahim. Today we're going to start the new topic that is about the covalent bonding. And in the last topic we have covered, which was ionic bonding. Okay, now we will see that what is a covalent bond. Now we will discuss that how a covalent bond is formed. From the name, whenever the covalent bonds comes, it means that in these electrons are shared electrons. In ionic bonding, if you remember, we talk about there is a loss or gain of electron. But here the share of electron, they are sharing the electron. Now, for example, if you see they have given the example of hydrogen. If you see the hydrogen has one electron only. Hydrogen has one electron only, and it is in there is last first shell. First shell is its last shell. And there is another hydrogen. Now there are two hydrogen atoms. In first shell, if you remember, how many maximum electron can accommodate in first shell? Yes, Ahmed, do you know? In first shell, maximum how much you can put? In first shell, maximum 2 you can put. In second shell, maximum 8 you can put. And third shell also you 8 can you put. So now is first shell is its last shell, or you can say it's the first shell. So how many it can have? Maximum 2. How much it has now? Only 1. It means that it needs one more electron to complete the last shell. So now what will happen? These two hydrogen atoms, they will come in such a way that their last shell will overlap over each other. This is one hydrogen atom. This is another hydrogen atom. So their first shell is overlapping each other. How many electrons they have? One. So this is for this hydrogen and this is for this hydrogen. They come in the center now. So now these two electrons, now they make what? Pair of electron. Pair of shared electrons. A pair of shared electron they made. So now this shared pair of electron, when you will count the electron for this atom, so you'll count both. 1, 2. So its first shell is complete. Then you will count for this hydrogen. Again, you'll count both 1, 2. So its first shell also complete by sharing. So when they make the bond like this, so that is known as covalent bond. One hydrogen atom sharing its last electron, that's one, and here they're making this bond. So now when they share this one, so this is nucleus. This is also nucleus. Nucleus of this hydrogen and nucleus hydrogen, because electron has which charge? Negative. And nucleus has positive charge. So then these positive nucleus and these negative, they attract each other. So this nucleus want to pull these electrons, and this nucleus also want to put these electrons. So in that way, they attract each other. You can see here the force of attraction. You can see by both nuclei. So like this, the covalent bond is formed. Once again, the valence electron or the last electron, the atom share their last electron and make the electron pair, and then the covalent bond is formed. See here, the covalent bond is a bond that involves sharing of electron pairs between non-metal. So which type of elements they make the covalent bond? Which non-metals? And when we talk about ionic bonding, if you remember, so ionic bonding, we said that it is between metals and non-metals. Covalent bond between non-metals and non-metals. The ionic bonding was metals and non-metal. So here when non-metal, they share electron with each other, which electron they share the last electron, so that's known as covalent bonding. Non-metal achieve the stability of noble gases by either gaining electron during the formation of ionic bonding. They're saying in ionic bonding, non-metal, they gain electron, but here they will share electron. Non-metal can also achieve the stability of by sharing electron. Now saying that why bonds are formed. The question comes that why bonding happens. So the answer is really simple, that every atom wants to get stable outer shell, stable outer shell, or it want to get the complete last shell. So here first shell is the last shell. It has one. So when it will share, so it will count for both. So its last shell is complete. Also for this complete. So by this way, by sharing, they also complete their last shell. So this type of bonding is known as covalent bonding. Covalent bond is the attraction between positive nuclei of bonded atoms. Now, which is nuclei? Talk about this one nucleus. It is between them and between the shared pair of electron. So they have attraction with each other. So by this way, they attract each other. So then the formation of covalent bond between two hydrogen atoms to form a hydrogen molecule shown below. So here they are saying that they have given the example of hydrogen atom. And which bonding this is? Covalent bonding. Did you get it? Please confirm. After that, the drawing the covalent molecule with single bonds. Now, if you see that a single covalent bond, why a covalent bond is known as single covalent bond? Bonds have, this covalent bond has three categories. Number one, single covalent bond. Number two, double covalent bond. Number three, triple covalent bond. What is the difference between them? Now, when each atom, for example, this chlorine atom, it is sharing one electron here, and this chlorine atom also sharing one electron. So how many pairs you are getting? One pair. You are getting one pair of electron. So at that time, this covalent bond is known as single covalent bond. And if they will share two, and here you have four electron, then double. If you will become six, then triple. So simply, if they ask what is the, you can say, single covalent bond, when the atom they share only one electron. So that is known as single covalent bond. What is valency? Valency is the number of electrons that atom may lose or gain. For example, if you will go in further detail of valency, now sodium, you know the sodium in group 1, sodium has 11 electron in total. So now if I want to draw the structure for sodium, so I will write 2 here, then I will write 8 here, second shell, then the last shell, the third shell, that is also 1. So if I want to write the configuration, I will write 2, 8, 1. It means that if this sodium want to complete its last shell, so what it will do, it will lose this one. It will lose this electron. After losing, how many shells left? Two. Which one? 2 and 8. So they are complete. So by this way, sodium will get the stable outer shell by losing electron. So how many electrons sodium can lose? It's 1. So it is valency is 1. So if you talk about the valency of sodium is what? 1. So it is losing. So we can say plus 1. In the same way, if you see the chlorine total has 17. And I want to draw the structure of chlorine. So I will write 2 in the first shell, then 8 in the second shell, then how many left? We wrote 2, 8. And then how many left? 7. So 7 will come in the last shell. So it means that if it want to make the last shell complete, it has two possibilities. Possibility number one, it lose all 7, then 2 will be left. Possibility number two, that it gain 1. So which is easier for this to gain 1? So what will do? This chlorine will gain one more electron. So it's become now how much? 8 instead of 7. So how many it gained? 1. So its valency is also 1. But it gains, so it's known as -1. Now see the definition. Valency is the number of electron that an atom may lose, like sodium, or gain, like this one, or share, like this one. So then that is known as its valency. The number of covalent bonds that an atom can form is equal to the valency of the atom. Now, for example, sodium chlorine can form how many covalent bonds? One. Why? Because its valency 1. So like this, you will know. For example, you see here the detailed group 1. All the atom in group 1, they have valency 1 and the charge +1. All group 2, they have valency 2 means charge +2, like this. If you see in the periodic table. Did you get this one? Please confirm. Okay, now see here, if you see the periodic table, this is group 1. All the members of group 1, they have, what is the valency? They have 1. And what is the charge on them? +1. Group 2 also have the valency, what? 2 plus, mean the charge valency is 2. Group 3 has valency 3, charge is +3. This is +-4, you can see here. This is 5 is -3. This is -2. This is -1 and this is 0. So you should know the periodic table valencies. Group 1, 1 like this. So this will help you when you will form the bonding. Now here they have given the different examples again. For example, here you see the first one. In the first one, they have two atoms. One is hydrogen, other is chlorine. If you draw the electronic structure of hydrogen, it has only one electron. For chlorine, what you have? Two, 8, and 7. So here when they draw the bonding, as I told you, they will draw only the last shell. These first two shells they will not draw. So if you draw the you can say last shell, so there are 7. 1, 2, 3, 4, 5, 6, 7. Hydrogen has 1. So this is for hydrogen and this is for chlorine. So now if you count for hydrogen, you will count 1, 2. So it means hydrogen become 2 and last shall become complete. When you count for chlorine, you will count 1, 2, 3, 4, 5, 6. This is 7 and this is 8. So this pair is known as shared pair of electron. This is known as shared pair of electron. So now hydrogen and chlorine, they are sharing one electron, and after sharing one electron, their last shell is complete. So this type of bonding is known as covalent bonding, but they shared one, so it is known as single covalent bonding. After that, if you talk about the hydrogen, in the hydro, this is which water? The water molecule. What is the formula of water? H2O. It means there are two hydrogen atoms and there is one oxygen atom. How they share the electron with each other? So here hydrogen has, if you want to draw the structure of hydrogen, hydrogen has only one. This has only one, and oxygen has 6 in the last shell. Total oxygen has 16, but how they will do? For example, here total 16. So 2 in the first shell, 8 in the second shell, in the last shell is 6. So that last shell you will draw here. So here again, I drew the oxygen 1, 2, 3, 4, 5, 6. So here one hydrogen atom will share one electron. Like this you can see here. And now if you count the for hydrogen 1 and 2, hydrogen is complete. But oxygen, how many? 1, 2, 3, 4, 5, 6, 7. So it's not complete. So hydrogen will make another bond. The oxygen make another bond with another hydrogen. So here now, if you count now, this is 8 now. So for oxygen also complete. This hydrogen also complete. So here you can see this is H2O molecule in which how many hydrogen atoms involved? One. But another hydrogen atom, so two hydrogen atoms together. But how many oxygen? One. So the formula is H2O. So this is how the hydrogen bonding is formed. But here once again, if you see here with this hydrogen and oxygen sharing one electron, for this oxygen hydrogen sharing one, so this is also known as single covalent bond because they share one and the other one they share with the other one. But if they share two with the same one, then it is known as double. We'll see later on the example of that one also. So this is the another example of the covalent bonding. Now see here. For example, now here you have a formula that is what CH4. In the organic chemistry, you'll see this is CH4 is methane. If you see how many atoms of carbons are here, one. How many hydrogens are there? Four. So now see the how the carbon is attached. For example, here if you want to draw it again, you will draw the carbon. In carbon, in the last shell, how many you have? In the last shell, you have six because carbon has no if you see the carbon has total 6. So in first shell 2, in second shell 4. So if I not draw 4, so I'll write 1, 2, 3, and 4. This is the second shell. Now it needs how many more? It needs 4 more to make the 8, then last shell will be complete. So what will do? It will go with one hydrogen, and if you see this hydrogen, it will make a bonding this one hydrogen. Okay, so here now this is hydrogen electron. So now for this hydrogen it is complete because 1 and 2. But how many carbons now? 1, 2, 3, 4, 5. Still it's become 5 now, but still it need how many more? 3. So then another hydrogen will come here and it will make and this one. Now it's become now 6. How many needs? 2 more. Another hydrogen atom will come here and now it's become how many? 7. It needs one more. So another hydrogen atom will come here and then it will become 8 now. So if you want to count for carbon, 1, 2, 3, 4, 5, 6, 7, 8. So now carbon is also complete and all 4 other hydrogen they also complete. So by this way, the covalent bond is formed between carbon and hydrogen. And how many atoms of hydrogen? 4. How many atom of carbon? 1. So this type of bonding also covalent bonding, and here they are sharing how many? 1 1. So once again this is also known as single covalent bonding. Now, if you see this example, this is another example. This is nitrogen. If you see the nitrogen has how many? 7 in total. And if the nitrogen has 7, so it means that in first shell 2 will come and second shell 5 will come. It means how many it needs more to complete the second shell? 3 more. If you add 3, that's become 8. So one hydrogen, two hydrogen, three hydrogen. So three hydrogen, they share one one. With this, now nitrogen is complete. 1, 2, 3, 4, 5, 6, 7, 8. So now nitrogen is also complete and hydrogen is also complete. So formula is NH3. That is what? Ammonia. So like this, it's also because this at hydrogen is sharing one electron with nitrogen. So this is also known as single covalent bond. So this is another example. In the exam, they will tell you to draw the structures like this. So you should know about this one. Is it clear? Please confirm by message. Okay. Now, if you see here in this one, so you see the nitrogen, as we just discussed now. Nitrogen has how many? Seven. So in first shell two and second shell five. So it needs how many more? Three more. Then it's become eight. Then last shell will be complete. So if you have two nitrogen, for example, N2, this is a nitrogen molecule. Nitrogen is making bonding with nitrogen. Now see here. So each nitrogen giving three, one, two, three. This nitrogen giving also one, two, three. So each nitrogen is sharing three electron. So how many pairs you have? One, two, and three pairs you have. So when the covalent bond is formed in this way, so this type of bonding is known as what? Triple covalent bond. So if you see it here, so when you want to count, for example, want to count for nitrogen, you will count one, two, three, four, five, six, seven, eight. For this nitrogen, complete. Now, if you want to count for this other nitrogen, so again you will count in the same way: one, two, three, four, five, six, seven, eight. So these six electrons counted for this nitrogen also and this nitrogen also. So two plus six, eight. Two plus six, eight. So by this way, they make the covalent bonding, but here now they share three electron. So this is known as triple covalent bonding. Now next example is carbon and with oxygen. So carbon with oxygen, what is the formula? CO2. What is that? Carbon dioxide. So this is a gas. So now if you see the carbon, we know that carbon has four. For example, carbon has how many? Total four. So it means first shell two, the second shell two. Oxygen total how much it has? Eight. So in first shell two, then six. So if you see the carbon has how many? Two, and oxygen has six. So if this carbon want to make last shell complete, so it needs how many more? Six. And this oxygen need how many? Two. So now see that this carbon is making the covalent bonding with two oxygen, one and two. And how they will share with each other, if you see here, so this carbon will share with two electrons here and two electrons here. So now they are sharing two, and this oxygen is sharing two, and this oxygen also sharing two. So when they share two electron, that type of bonding is known as double covalent bond. And here, if you want to count for them, for example, for this oxygen, if you want to count one, two, three, four, five, six, seven, eight. And if you want to count for this one, oxygen, one, two, three, four, five, six, seven, eight, complete. And if you want to count for this carbon, one, two, three, four, five, six, seven, eight, again, for all of them to complete. So this is what the covalent bond. In the exam, what they will do, they will give you a formula like this. They will say to you, N2, draw the covalent bonding diagram. So you'll draw like this. And then if in the exam they'll say, okay, draw the covalent bonding for CO2, then you draw for this one. Really important. So you will draw the structure for them like this. So this is known as the covalent bonding. This one, as we said that this is which bonding is known as triple covalent bonding. And this one, because they're sharing 2, so that is known as double covalent bonding. So this is how the bonding is formed: single covalent bonding, double covalent bonding, and triple covalent bonding. Is it clear? Now we are going to compare between ionic bonds and covalent bond molecules. So first of all, we see these are the properties on which we will compare them. For example, state at room temperature, they are solid, liquid, or gas. Melting point and boiling points, they are solubility in water, they are soluble in water or not. They are soluble in organic compounds, organic solvents or not. Or after that, the conductivity, the electricity can pass through them or not. So we see the first one, the state at room temperature. They're saying ionic compounds normally they are solid at room temperature. Ionic compound mean the compound which are formed due to ionic bonding, so they are known as ionic compound. So normally or generally they are solid at room temperature. If you have simple covalent molecule, so they are liquid, gas, or sometimes solid, but even their melting point is very low. So they are found at room temperature. Melting point and boiling point, ionic compound, they have really high melting point and boiling point. For example, if you want to melt them, you have to provide them lot of energy. The simple covalent compounds, they have low melting point and boiling point because most of them are the liquid and gases. So it is easy to boil them or to melt them. And they use a word volatile. Volatile means something will convert into, for example, is a liquid, like you can say petrol. You put in a room without heating, after some time, you will find that all the petrol is evaporated at room temperature. So anything which will evaporate at room temperature without heating, so that liquid is known as volatile liquid. So normally they are saying that most of the common compound they are volatile. Solubility in water. Ionic compound they are highly soluble. Means if you mix them with water, they are completely soluble in water, most of them. Then, if you talk about covalent compounds, so they are not much soluble as the ionic compounds. So it means their solubility is really low in water. After that, solubility in organic solvent, insoluble. For example, inorganic solvent means the organic solvent means what? For example, you have the alcohol, that is the organic solvent. If you bring like sugar in the alcohol, it will not mix. I'm giving the example. Okay. So it means that the ionic compound they are insoluble, or in other words, not soluble in what? Organic solvents. But the covalent compounds they are soluble in organic compound. Now conductivity. It means that they pass through the electricity or not. They are good conductors of electricity or not. Now ionic compounds conduct only when they are molten or dissolve in water. For example, if you have NaCl, sodium chloride, it is in which form now? Solid. If I want to pass electricity in through this one, so no electricity will pass because it is solid. But if I same NaCl, I mix with water and now it is a solution. So when if I want to pass electricity through it, it will pass easily. Or I will take NaCl in a container and I will heat it. Now NaCl will what? Melt. NaCl will melt. When NaCl will melt, so at that time, if you pass electricity, so it will also pass. So, ionic compounds are good conductors of electricity if, what is the condition? Number one, if they are molten. Number two, or they dissolve in water. So, these two conditions on which they are conduct the electricity. After that, the covalent compounds or covalent molecules do not conduct electricity in any state. Either they are solid, or they are liquid, or they are gas. In any state, they do not conduct electricity. So, this is the main difference between them. For example, once again, room temperature, state at room temperature, melting point, solubility water, organic solvent, conductivity. So whenever you can want to compare them, so you can compare them by these properties. In the exam, sometimes they ask a question that write a comparison or compare the ionic compound and covalent compound, write any 2 points. So you can write any two from these. If they ask any three, you can write any three, this one. So this is really important. The, you can say, table, you have to memorize this one. Now you have intermolecular forces of attraction. What is intermolecular force of attraction? Intermolecular forces of attraction are weak attraction that exists between neighboring covalent molecules. Now, these forces are much weaker than covalent bonds within the molecules. Intermolecular forces are broken when molecules are heated during the change of state. Covalent compounds bonds, however, do not break during the change of state. Covalent bonds within the molecule do not break while melting or boiling. Now, what is the example I want to give this one? Now, see here. You have water. Got it? And formula of water, you know that. What is the formula of water? I will write here, it's become more visible. H2O. This is the formula of water. If I want to draw the structure of this one, I will write this one: hydrogen, then you have oxygen, then another hydrogen. Got it? So they have a bonding between them. Now there is another water molecule. So now if you talk about this molecule, it has covalent bonding between hydrogen, oxygen, and this oxygen, this one. So this is one molecule formed due to covalent bond. This is also have covalent bonding between them. But when these two molecules come close to each other, so they do not lose, gain, or share electrons within each other, but still they have a force of attraction. So that force of attraction is known as intermolecular force of attraction. So the same molecule, mean water molecule, they have a small force of attraction. So when you heat them, so what will happen? This, they will go away from each other. They will go away from each other. Understand? In the same way, the hydrogen, this is a molecule, they have bonding. But this hydrogen and this hydrogen, they do not have bonding, so they have attract each other. So they are saying that intramolecular forces are broken when molecules are heated during change of state. But covalent bonding, it will not happen that this hydrogen will go away from this hydrogen separate. No. Only two molecules, they will lose their force of attraction. So this is known as intermolecular force of attraction. The fact of these forces are weak explain why covalent compounds have. So this, it shows that why they have low melting and boiling point, because the force between two different molecules is very weak. So this is known as intermolecular force of attraction. So due to this reason, the covalent compound have low melting and boiling points. Now, this is an advanced comparison between ionic and covalent compound. We just compare it now depending on covalent bonding. Due to on state at room temperature, we talk about melting and boiling point. We talk about conductivity, and we talk about their force of attraction. Now we'll talk about advanced melting and boiling points. We will see in detail. Ionic compound, they have high melting and boiling point. What is the reason? Because the strong electrostatic force of attraction between ions and the crystal lattice require a lot of energy to break them. This is why the ionic compound always exists in solid state at room temperature. Now we see covalent molecules, they have low melting and boiling point. What's the reason behind that? Because weak intermolecular force of attraction. So if in the exam the question comes that why the ionic compound have high melting point and boiling point, you can say because strong electrostatic force of attraction between ions in the crystal lattice. And why the covalent compound, they have low melting and boiling point? Because the weak intermolecular force of attraction are there. So when the covalent compounds are heated, this is why the simple covalent molecules exist in gases and liquids or solid, but with low melting and boiling points. Number two, conductivity. Now, okay, we said that the ionic compound conduct electricity, but when they are solid, or when they are liquid, mean what? Molten, or they are in a solution. Once again, they conduct electricity, ionic compound, but two conditions. Number one, when they are molten. Number two, they are in solution. Now, if you see here, the what is the reason? Electrical conductivity requires the movement of charged particle. For example, if you have sodium chloride, NaCl, if you see its structure, sodium is positive, chlorine is negative. So these are charged particles. So they cannot conduct electricity unless they cannot move. In solid, they cannot move. So they cannot conduct electricity. But in molten, they can move, so they can conduct electricity. So although the charged ions are available in a solid state of ionic compound, ions cannot move due to strong force of attraction. When dissolved or melted, ionic compounds conduct electricity because the ions can move freely now. So this is the main reason behind. So if in the exam the question comes that why ionic compound do not conduct electricity when they are solid, what is the answer? Ions cannot move due to the strong force of attraction. And if the question comes why they conduct electricity when they are molten or solution, you can say ionic compound electricity ions because in the solution, because ions can move freely in what? In molten and solution. And if you talk about the conductivity in covalent molecules do not conduct electricity in any state because there is no moving or free, or you can say mobile ions or electrons. In covalent compounds, you will not find any ions or any free electron. So due to that reason, you can say that the covalent compound, they do not conduct electricity. So this is the advanced comparison between the ionic and covalent molecules, and which 2 points we discuss: melting point and boiling point, and other is conductivity. I hope you got it. Did you understand it? Okay, now you have questions here, and this is a past papers already solved, but you have, for example, question number one: covalent bonds are formed when electrons are. Covalent compounds have electric connectivity. They have given the word. So can I say transferred? Transferred. In covalent bonding, no transfer of electron. Only what? Sharing of electron. So it means that here shared will come. And second one, they have high electrical conductivity or low. And now we just discussed that covalent compound do not conduct electricity, it means low. So this is the answer. The details are given here. Question number two. If you see this question, they're saying the electronic structure of an atom is given, shown here. This is X, this is Y. it has only one electron in the first shell. It has how many in the second shell? One, two, three, four, five. In first shell, it has two. This one. The structure is for X, you have one, and Y, you have five. So how many it need more? One more, it's become two, and then it is complete. This five, how many it needs more? Three, then it's become eight, then it's complete. So what we'll do, so how many X, for example, Y, if I want to write the formula, the structure, so I will write here, okay, Y here. I will draw only the last shell. In last shell, how many? Five. One, two, three, four, five. Okay, I will write X here and I will write for it one. So it's become complete. X is complete now. And Y become how many? One, two, three, four, five, six. Then another X will come here. Then how many X is complete? And Y is become seven. So one more X will come here. This one. Now it is complete. So how many X you needed here? Three atoms. How many Y? One. So how the formula will be? X3Y1. So this is the formula. The D is the right answer. Okay. Now the diagram, which diagram does not show the outer shell electron in the molecule correctly? For example, hydrogen has how many? One. Fine. Hydrogen and chlorine. Hydrogen has one. Chlorine how many? It should be seven. Because if you see chlorine is total 17. So in first shell 2, then 8, then 7. They're talking about the last shell. So 1, 2, 3, 4, 5, 6, 7. It's also correct. Hydrogen again how many? 1. So it's showing 1 in all. Carbon total how many? 6. In first 2, then 4. So 1, 2, 3, 4. It's also correct. Here see chlorine. This chlorine is showing how many? 1, 2, 3, 4, 5, 6, 7. But this chlorine is showing only, this they did not draw for other 6 for this one. So this is wrong diagram. All other. For example, see which diagram does not show the outer shell correctly. This one is not showing because here they missed the chlorine and electrons. So this is how you will solve the question in the past paper.